Right, we're going to start off a lesson by looking at just two ancient accounts, how certain things were described in the past. Nothing there is beyond hope, nothing that can be sworn impossible. Nothing wonderful, since Zeus, father of the Olympians, made night from midday hide in the light of the shining sun, and sore fears came upon men. So what's that talking about? Well, it's talking about how the light was shining and then ceased to shine. So we changed from midday to nighttime. So what's that possibly about? Another quote from the 5th century BC. Day was all of a sudden changed into night. This event had been foretold by Thales, the Mycenaeans, who forewarned the Ionians of it, fixing for it the very year in which it took place. The Medes and the Lydians, where they observed the change, ceased fighting, and were alike anxious to have terms of peace agreed upon. So what happened in both of these quotes was a time where it was daylight, and then something happened that it became quite dark. It frightened people because they didn't understand the science. So what are we going to look at today? Our title is the eclipses. We're going to be able to, hopefully at the end of this, explain how eclipses happen. And you can see from this animation, what I've got is I've got our Earth orbiting with our moon orbiting around the Earth. We've got an object going in front of the sun, and we're actually seeing how the sun hits the planet at different points. So we're seeing things that occur because our Earth rotates around the sun. We are at an angle, and then we have our moon rotating around the Earth that is also at an angle. So what are eclipses? Well, there are two types. Solar eclipse happens when the moon passes between the sun and the Earth, casting a shadow on the Earth. The last solar eclipse over the UK was on the 11th of August in 1999. They're very rare in the UK. I was very lucky that I was actually down on Cornwall on the 11th of August in 1999 and saw the solar eclipse. What was quite shocking was at the point where the moon passed in front of the sun, it was actually quite scary because everything went deadly silent. All the birds stopped singing, and everyone was just stood in silence. And then at the point as the moon passed through and the sun started to reappear, everyone cheered and the birds started singing again. So quite a rare thing to see and quite an experience. So then we've got the lunar eclipse. That happens when the Earth passes between the sun and the moon. So it's the Earth going between them, and it casts a shadow over the moon. Lunar eclipses happen about every couple of so years, so we can see them quite often. So what's happening during a solar eclipse? When must the moon be for a solar eclipse to occur? So in our diagram here, we've got our orange there, which is our sun. We've got our planet Earth, and we've got the moon. So during a solar eclipse, the moon moves directly between the sun and the Earth, blocking the sun's rays from reaching a part of the Earth. Now, if you look at where the two yellow lines go, that is the small section of Earth that would see that total solar eclipse. And here's a diagram of it. So we've got our sun, and we've got our Earth, and we've got our moon going in between. And as you can see, light travels in straight lines. So if we follow the lines where they cross over and then go, we get what's called the umbra and the penumbra. Now, the section that's directly behind the moon that goes to planet Earth is the penumbra. It's the darkest part of the shadow. And that is where we see the total solar eclipse. We have the penumbra, which is the lighter part of the shadow, but we don't see a total solar eclipse there. We will see partial solar eclipses. So now what I'd like you to do is I'd like you to watch this YouTube video, and if you see the hyperlink at the bottom of the page, you'll be able to go to that. But be prepared. You need to have a pen and notepaper so that you can be writing down notes, because after that I'm going to ask you some questions. So I hope you were paying attention to that video. Right, what we've got here now is a set of questions. If you don't know the answers, then go back to the slide, press the hyperlink, go back in the video and press the hyperlink and watch the video through again. So what I want you to do now is pause the video, okay, so that you can answer these questions. So question 1, roughly how many miles away is our sun? Question 2, what 3 things do our sun give out? Number 3, what is a solar eclipse? Number 4, describe the umbra. Number 5, describe the penumbra. Question 6, what is the corona? Question 7, how often roughly does a total solar eclipse occur? Question 8, can a total solar eclipse occur anywhere? And when I say anywhere, I mean anywhere on the planet. If it can't, why? Question 9, why must you not look directly at the sun? And question 10, what theory was proven by Einstein's using a solar eclipse? And that was back in 1919. Right, have you answered all the questions? Have you had a good go at them? Okay. Right, so here's your answers. We're roughly 93 million miles away. Now be careful, because that unit is in miles, not in kilometres. The 3 main things that are given out by the sun is light, energy and heat. Number 3, a solar eclipse is when the moon moves directly between the sun and the earth, blocking the sun's rays from reaching the earth. The umbra is the darkest part of the moon's shadow and causes a total solar eclipse. Number 5, the penumbra is the outer segment of the moon's shadow and causes only a partial solar eclipse. Notice I've put on what effect it will have. Question 6, the corona is a circular ring of plasma that surrounds every star, and obviously our sun is a star. Answer to number 7, a total solar eclipse can roughly occur about every 1.5 years. Alright, question 8. A total solar eclipse can only occur over a certain region of the Earth because of the Earth's tilted axes and also of the Moon's tilted axes. So it only appears across the Earth in a very small band. Question 9. You must not look directly at the sun or even use sunglasses. They're not strong enough. You need to use special glasses. Why? Because it can cause eye damage and even blindness. And then finally, question 10, Einstein's theory. By using a solar eclipse in 1919, he found that he was able to prove that large masses could bend light. So let's look at the other type of eclipse, the lunar eclipse. Where must the moon be for a lunar eclipse to take place? So if you look at our diagram there, we've got the sun, we've got planet Earth, and then we've got the moon behind Earth. So actually Earth is between the sun and the moon. Right, so during a lunar eclipse, the moon is on the opposite side of the Earth to the sun, blocking the sun's light from reaching the moon. Remember, the moon reflects light. So here's our diagram, and you can actually see from our diagram, again, our rays of light travel in straight lines, but we can see the shadow, the umbra section, is actually much larger, and the penumbra is much smaller. So again, if you look at the bottom, there is a hyperlink. If you click onto that hyperlink, it will take you to a nice YouTube video, and again, you need to be making notes. So here's some questions. How often does a full moon occur? Now you should have been doing about full moon and the moon phases. Question 2. How often does a total lunar eclipse occur? Question 3. Why don't we get a lunar eclipse every month? Question 4. What part of the shadow does the moon need to be in for it to look red? Question 5. Why do eclipses only last a few minutes? Question 6. Why do you think ancient people were frightened of eclipses? And question 7. What would a lunar eclipse look like if you were an astronaut standing on the moon? Now, again, if you don't know the answers, go back to the previous slides, have another watch of the video, write down some notes, and then when you think you've got the answers, then you can move on. So you need to pause this video, make a note of these questions, see which ones you can answer, which ones you can't answer, go back, check them, and then when you're ready, press play again on the video and you can then answer the questions. So hopefully you've taken enough time. Right, here's the answers. Full moon occurs every month. Right, a lunar eclipse occurs roughly about every 2 years. We don't get lunar eclipses every month because the moon's orbit is tilted and it needs them to be lined up. Question 4. The moon needs to be in the darkest part of the shadow that we call the umbra for it to appear red. Question 5. Eclipses do not last long because the moon is moving on an orbit around the Earth, so we have movement. Question 6 goes right back to those original quotes that we had at the start of the PowerPoint. People feared eclipses because we didn't know about the science, so we thought there were signs of something bad or something evil, so people got frightened by them. And finally, question 7. If I was stood on the moon, the lunar eclipse would look like a solar eclipse. It would actually be the Earth being between the sun and where I was standing on the moon. Quite an interesting idea. Right, task for you. Okay, you'll need to press pause on this. So you've got a start of a sentence and the finish of a sentence. Can you match them up? Give yourself plenty of time, right? And read through each statement carefully. So press pause on the video, have a go at matching the sentences up, and then when you're ready, press play and we'll check your answers. Right, how were your answers? Did you get them right? Did you get some of them wrong? Have a look, see which ones you got wrong, and see if you can think of a reason why you got them wrong. Okay, have a good look through, press pause on the video and give yourself some marks. Right, okay, next task. Next task is going to be quite difficult. If you look at the top there, I've asked you to go and find 3 different sized circular objects and asked you to draw and label. Now you need to think about this. So press pause and you're now going to go and look for 3 objects. It could be a coin, it could be a sellotape, it could be a mug. Could you draw the 2 diagrams that are at the top and then label one as solar eclipse and one as a lunar eclipse? So press pause on this and have a go at doing that task. Then, so now you've completed that task using your same 3 objects, or you could use your original diagrams that you've done. Can you do the next task where you're going to add keywords in for the solar eclipse and then keywords in for the lunar eclipse? Quite a difficult task. This is going to take you a good 10 minutes to get these drawn. Okay, so press pause and have a go at doing them, and then again go back and check in the PowerPoint to see that you've got them right. Remember, the umbra is the darkest part of the shadow and the penumbra is the lighter part of the shadow. Right, so we're now ready to move. Okay, here's an exam style question. Solar eclipses are rare events that only happen occasionally. A total solar eclipse generally only happens about every 50 years in the UK and about once a year in the world. The frequency with which they happen is not set, so the time in between each one is different every time. So, can you answer these exam questions? Can you say, what is a solar eclipse? Question 2. What is the difference between a partial and a total eclipse? Right, question 3 and 4, you may need to go and have a look at some research. Okay, question 3. During a total solar eclipse, the moon exactly covers the sun, meaning that in the sky, they appear to be the same size. Are they really the same size? Why do they appear the same size? Think about distance. Hold your finger up in front of your eyes, about 5 centimeters away from your nose. Now take your finger fully away at arm's length. Does your finger look bigger or smaller? Think about that. Question 4. What famous theory was proven during the 1919 solar eclipse? Explain briefly how it was proven. And here's a little hint for you. The man in the corner with his tongue stuck out is Albert Einstein. So press pause and have a go at answering these 4 questions. Right, let's have a look now at just a little bit of a mini assessment. When does a lunar eclipse occur? Is it A, when the sun is between the earth and the moon? When earth is between the sun and the moon? When the moon is between the earth and the sun? When earth is between the sun or another celestial body? Yes, that's right. When earth is between the sun and the moon. If you pick the wrong one, why? Go back and check. When does a lunar eclipse happen? Does it A, half moon, B, full moon, C, the equinox, or D, none of the above? Were you right? B, a full moon. What is a solar eclipse? Is it when the moon comes in between the earth and the sun? B, when the earth comes in between the moon and the sun? C, when the sun comes in between the earth and the moon? Or D, when the sun does not reach earth? Yes, that's right. When the moon comes in between the earth and the sun. What do you mean by a blood moon? Is it a total solar eclipse, a partial lunar eclipse with a red glow, a total lunar eclipse with a deep red glow, or none of the above? Well, it's a total lunar eclipse. If we're talking about the moon, we're talking about lunar, and it gives us a deep red glow because it's in the umbra, and hence we call it a blood moon. Right, here's a little bit more of a challenge for you. Right, when light from the sun hits the Earth's atmosphere, it refracts, and we see a blue sky. So here we've got sunlight going into a prism, and it refracts at different levels, and we get the spectrum: red, orange, yellow, green, blue, indigo, violet. Mnemonic phrase: Richard of York gave battle in vain. Now, Einstein in 1919 proved that light could bend around large masses. Is that relevant? Let's think about it. Using the information here, Why do you think we see a red moon? Now, the answer for this, if you're talking at a low level, you're only going to talk about refraction. If you're talking at being at a higher level, we might be talking about refraction, reflection. We might be talking about Einstein. Your task now is to research and see what your answer you can come up with for this challenge. Hope you did all right on that and that you've learnt something interesting.